Hey, how's everyone doing? We got Tiffany and Jillian here. I was wondering if we could work on homework number 2, chapter 2 homework. We've done chapter 2 homework. Yeah, let's do it. People were wondering about the quiz also. Nope, Mubot, don't go away. Mubot was going to leave us. Mubot.
I am Mubot.
Thank you, Mubot. Let's give out some 50 points to everyone who's here right now. Jillian, good to see you. And let's hop over here and do some chapter 2 homework. So I'm going to pull up chapter 2 homework to start. Remember, if you're in the chat, you get to pick the direction we go. So pick ahead and choose. And sorry for starting a tiny bit late. I was having my pancakes. I have no more pancakes now. Pancakes are gone. Just grabbing some lunch between classes right there. Pancakes for lunch, pancakes for dinner. I mean, there's no wrong time to have pancakes, right? Or am I wrong? So chapter 2 homework starting up right here. I'm getting it loaded up in the background right now. Come on, my Pearson. My Pearson. Assignment manager. And assignments are loading up. It is slow lately. It's just taking a while. Chapter 2 homework. Getting loaded up. It feels pancakes all day. You can just have pancakes anytime you want. And here we go. Let's start some chapter 2 homework. So this is stuff we'll be definitely covering at the start of next week. This is categorical or quantitative data. Put C or Q in the chat to follow along. This is categorical or quantitative data. Is this categorical or quantitative? It's number of home runs Mark McGwire hit in a season. So is this categorical or quantitative? On different numbers? Yeah, in your numbers, I can kind of see it. It's quantitative. I'll look at your numbers right there, Tiffany, as we do it, and I'll kind of talk about those. I can see Tiffany's stem and leaf at the top right here. Now, people get confused about stem and leaves. This is quantitative. When you have a stem and leaf right here, everything's walking. There we go. Let's get the stem and leaf up. And when you have a stem and leaf, the way a stem and leaf works, there's syllabus for 320, is this is just a number line. These are not observations. And I think that's what confuses people a lot of times. So this is the 70s, the 60s, the 50s, the 40s, the 30s, the 20s, the 10s, and the 9s. So Tiffany, yours has the highest value of 71. And I see that because on Tiffany's data, I'll draw what Tiffany's looks like here at the top, and I'll try to kind of refer to hers, is up here at the top, they have a value of, and is this right, Tiffany? Yours says a 1 right here. So Tiffany has the most home runs Mark McGwire hit in this theoretical season of 71 home runs. Now, looking at my data right here, what was the least amount of home runs that Mark McGwire hit? And I've kind of altered this. Sometimes you might see something like 1-6 equals 16. Always look at the key on the bottom. So 1-6 equals 16, such as like 2-1 equals 21. Now, it doesn't always have to equal 21. Great job, Jillian, right there. 20 points, all these answers. It doesn't always have to equal this. What if we asked how many milliliters of something are in a solution? Well, then 2-1 could be 2.1. So please always look at the key on the bottom. That's where sometimes people get tricked on a test. Always look at the key to see how the numbers are represented. And you'll see this on ours right here. It is number of home runs, and notice the key saying 7-3, 7, and there's the dash. It's the dash going all the way down the center, represents 73. Now we have some terminology right here that we need to know. This terminology is related to the shape of a distribution. The shape of a distribution, we talked about this today with the visualization, has a few key concepts. I'll zoom in on it. You're going to have to read my bad handwriting here. The shape of a distribution has in it the modality, the skew, which is either skew or symmetric, or outliers and gaps. And these are all things of shape. So when we look at the shape, we want to ask how many mountain peaks are there, and that's the modality. So modality or modes are how many peaks to the mountains. And imagine you were to go out with your friends here, and you were to go to this mountains. How many mountains are there in this range? So you go with your friends and you say, let's go hike some mountains. We need to scale you to size right here. How many mountains are there in this mountain range? It's not the biggest of mountains, I'll say. How many mountains are there in this mountain range? Best animations on 201 ever. How many mountains are there in this mountain range? Remember, we want actual mountains right here. How many mountains are there in this mountain range? There's just one. And that's what we mean when we say it's unimodal. There is one mode. Mode means like most common area. You might say, well, isn't there two? It's just a little hill. That's not really a big hill right there. We might eventually see a bimodal distribution, which is possible. Bimodal should look at least something like that. I mean, at this point, you might argue that there's some sort of second mountain right there, much smaller, but you could see much larger mountain ranges where there's two clear mountains. So it really just depends if we have kind of something that is primarily unimodal. I'd call that unimodal, where we might have something that has some bimodality or very strong bimodality right here. So modes is how many common areas there are. But sometimes we don't have modes. In instances where we don't have modes, we would have something called uniform. Can anyone describe what a uniform distribution might mean when we say uniform? So break down what uniform means when we say uniform. I mean, just think about what uniform means. This is what? It's not unimodal. It's primarily, and they don't always look like this. They can look a little like when you see them in real life. They might look something more like this right here. They might look more like this. Kind of one big thing, kind of one big form, and it doesn't have any real peaks here. It's like one big mountain. We go up here and then just it's one mountain across. One form. Great job there, Jillian and Tiffany following along. This is what you usually see for uniform. It's not going to look perfect. The perfect uniform is just completely flat. You don't always see that. This is still uniform, though. It's not really multimodal, which means multiple modes. You really want to see clear mountain peaks, which makes the answer to our question pretty easy. Our distribution right here is unimodal. I almost made a mistake. See how there's one peak to this mountain? Unimodal. Next question right here says, is it left skewed or right skewed, or is it symmetric? And for this example, I like to do it inside of R right here because I think it really helps to see this. I have a saying you're going to hear a lot: left to the low, right to the high, right to the high, left to the low. I need to learn my own saying. Right to the high, left to the low, whatever way the tail goes. Let's take a look at what this means. Let's just make a distribution. You don't need to know how to do this, but I'm going to make a distribution right here. And I want you to tell me, is this right skewed or left skewed? Is the distribution I made right there right skewed or left skewed? Right to the high, left to the low, whatever way the tail goes. You might be saying, what are you talking about the tail? Well, think of a little monster man. The monster man is going to have a face. Let's draw it on here. Here's his monster man face. And then the monster man is going to have a monster man tail. So does it go to the high side? Does his tail go to the high side, which is right skew? Or does his tail go to the low side, which is the left skew? Right to the high, left to the low, whatever way the tail goes. And I think yours should be very similar, Tiffany. I think yours should be very, very similar. And the monster man's tail goes to the right. Well, how about this one? How about that distribution? That's left skew because the monster man's tail goes to the left. Sometimes we have symmetric data, which is not so well described. Oh, did I make a mistake? Oh, our norm. Sometimes we have symmetric data right here, which doesn't really have any skew to it. Oh, yeah, you bet, Miles. Yep, let's hop on a Discord after this if you can, and we'll get on there. And I think I'm not teaching soon after this. We'll try to make sure we get on there. Thank you, Miles, for asking. We'll try to get jump. And OIT has helped a few people because sometimes the problems are more like a computer iOS issue. So we might have to you might have to swing by OIT. I've helped a lot of people, probably like 85, 90% of problems I've helped. And then sometimes that 10, 15%, I'm like, you got to swing by OIT because it's an iOS issue. So this is a symmetric distribution. Now, how does our distribution look? Now, this is the hardest question on this one. Our distribution, now be very careful. I'm going to ask it the tricky way. I'm going to draw my monster man, and my monster man's tail goes a little bit in this direction. Be very careful. Don't hit the enter button yet. Awesome. Let's do some 320 after this. You got it, Lindsay. Be very careful. What way does that monster man's tail go? I want you to tell me low or high. And it's not very skewed. I have disagreements with this question. We'll do some 320 right after we do the homework. So what way does this monster man's tail go? Is it left or right? Be very careful. Very common error on this question. This is one of the ones that is very commonly missed. I've missed it before. Is it left or right skew? It is left to the low. Tiffany, 20 points right there. Tiffany, that's exactly what I wanted to hear. It's left to the low. You say to me, but Brian, I know the way things go. That's right skew. That's right skew right there. But I say to you, the number line is backwards. And you say, oh, how dare you? You're trying to trick me. That's not fair. We need to flip this image. And if you look now, the number line is properly oriented. It's not that strong of a skew. So this is the answer. And I think it's always left skew. But now the number line goes from 0 to 7. If you have it the other way, it's backwards. So it's just very common that people look at it backwards. So this is left skew. Very little left skew. It's a very small amount of left skew. The center of the distribution is kind of where the peak is at. And that's going to be in the 40s right there. Good stuff. Just where the peak, the modal area. And what is the range of the home runs? So this is where we have to know how to read the stem and leaf. Remember we were practicing this earlier? We said it earlier, so check out the chat and follow along. I think your numbers are the opposite. They could possibly be. Remember the homework, you get infinite attempts. You can click similar question if you miss something. So you do get infinite attempts on the homework if you do miss something. I think it's usually left skew. I think it might be reversed, but I think it's usually left skew. So here we see it starts at 9 because this is 0, 9 representing 0, 9. 0, 9 is 9. I wonder if it would accept 0, 9. It should. And it goes all the way up to 73. I think. And it does accept 0, 9. Well, that makes sense. 0, 9 is 9. So it does accept it. Remember, this is the first number you'd have right here, and this is the second. What does it mean that 60s is blank? Someone asked that last time. What does it mean that the 60s is blank? Thoughts on the 60s being blank right here? What does that mean? Well, I know he hit 54 home runs in a season, 56 home runs in a season. There were no seasons in which Mark McGwire did what? So the 60s are blank. So it's like we looked, oh, how many home runs did he hit in 1989? Well, he hit 33. It doesn't tell us that, but we're pretending that's what he hit in 1989. No, he didn't hit any home runs that had amounts in the 60s. So there wasn't a season where he had like 62 home runs. So it's just no data right here. It's just you said he had 73 one season, 54 one season, 56 one season. He never had a season where he hit 60-something home runs. Do we see any unusual features? I guess someone could say, oh, is it going to be that? I've gotten this question right so many times. Wow. What do you think? It's A or B? I mean, B or C? B or C? We can't miss something this early in the semester. I mean, that's kind of high, but not too high. The further away it is, the more unusual it is. From my memory of what I've done. Oh, look at that. We missed it. We got to speed run it now. It is unusual, it's saying. It's saying that's a bit of an outlier. Oops. Oops, it's saying that's an outlier. We got to speed run it. I'm just doing that to show you if you get something wrong right there, what you can do. If you get something wrong, you can just redo the question. And if you know how to do the question and read it, look at this. Oh, that was just, oh, look, an unusual feature is 73. There we go. I did this question I was just practice right there. 20 points to Brian, just showing how to do the similar question, just in case you get something wrong right there. This is a dot plot right here, and a dot plot is going to display what kind of data. Important note to have that a dot plot displays what kind of data. Who knows what kind of data dot plots display? What kind of data do dot plot displays? Who knows what kind of data dot plots display? So look at the graphic. I'll help out. So what kind of data do dot plots display? Quantitative, just like histograms. And we were just doing a stem and leaf, so they can both display the same thing. Like you could make a dot plot of Mark McGwire's home runs, or you can make a stem and leaf or a histogram or box plot of his home runs. So it just displays the same type of data. Really good graphic right here. Mariam, good to see you here. Just practicing some chapter 2 and ask those questions. We're going to do a little 320, I think, after this. I think that was, yep, Lindsay asked about 320, you bet. Go ahead and put those 320 questions in the chat, Lindsay, if you want, and we'll do them next. All graphics. I need to set that on a quick key. Univariate, Tiffany right there, 20 points, univariate quantitative. That's a top tier answer. Another 20 points, great answer. So this is quantitative. It's how many hurricanes occurred, I guess, wherever we were at, because usually there's more than one a year. And we see here 1, 1. So there's 2 1s. So we've got it narrowed down to one of these 3 graphics. And then how many 5s are there? There is 1 5. So I think it's this one. Watch me get another one wrong here. Yeah, that's the only one, and there's only 2 1s. So I'm counting up that there is 1 5, and since there's 1 5, this one is the one right here. If you can see right there in my head. So we got it. How does this distribution look? How many peaks are on this mountain? How many peaks are on this mountain? So let's draw our mountain. How many peaks are on that mountain? And then we'll draw our little hiker guy. How many peaks are on that mountain? Or is it flat? Is that a flat mountain? Best drawings ever. How many peaks are on that mountain? Are there 2 peaks, bimodal? Is it flat? Like if it's flat, it'll look... It's so hard to see when that appears. There's 1 peak, you're right. If it was uniform, it would look like this. That's uniform, that's unimodal, and that's bimodal when it has 2 clear peaks. It is very clearly unimodal, having 1 peak to the mountain. Now when we say, is it left or right skew, or is it symmetric, we need to go right to the high, left to the low, whatever way the tail goes. And the number line is going properly, with the left being the low side, and the right being the high side. And so is it left skew or right skew? Left, right to the high, left to the low, whatever way the tail goes. So what is it? You draw your little monster man, and he's got his little tail right there. This one isn't very, very skewed. But right to the high, left to the low, whatever way the tail goes, this is most definitely a what skew distribution. Right skew. Great job, Tiffany. Another 20 points. Keep those answers coming. Earn all those points. More answers, more points. That's how we roll here on Stat 201. And next question. So now that we said it is skewed, and these are notes we're going to be covering, we have just talked about the what of the distribution. By saying it's skewed, we have talked about its what. By saying the distribution is skewed, we have just talked about the what of the distribution, which are key things we're going to need to know to talk about univariate quantitative data. This is all univariate, which means one variable, quantitative data. Univariate quantitative data, we just talked about its what, saying that it's skewed. So we said it is skewed. We just talked about its what. So it is skewed. We just talked about its what. And Tiffany's right. We're going to need to find the median because we just talked about its shape. And so we are going to use these classifications for the center and spread respectively since it is skewed. If it was normal, we'd use the mean and the standard deviation. So since it is skewed, we are going to use the median, and we're between these values. Now, if you notice, 2.5 is actually the only logical choice because we'd be averaging together 2 and 3. More on finding the median on the next 2 questions. So you would be averaging together 2 and 3, which it doesn't have the numbers in order. But if you were to, let's go ahead and do that. Copy to clipboard. And I'll show you how this is done. It's just more work than's needed. And we're going to order this. It's just a very large amount. We wouldn't ask this on the test. And the median is going to be if you go to the 7.5th number right here between these. So you need to find the middle number. And since there is no middle number, it'd be between 2 and 3. So it's always going to be for this one because you're averaging together 2 numbers. This one. We will be finding the median using data sets here in a second. So you'll get to see that on how to solve that. So it is the median because it's skewed. And then it wants to know the range. Hurricane values range from 1 to 5. Good stuff right there. I think it's got, describing unusual features. There's no unusual features. That's the one for this one. There are no outliers. There are no gaps. There's nothing really weird going on with this data. Next question right here. Zaid, good to see you, Zaid. We've got right here a bunch of numbers on the screen. Now, this is where having jump is a huge help. But I do also want to drop, does anyone have a TI calculator? Who's got a TI calculator? I've got a TI calculator. Maybe I don't even have it here anymore. Let me go to my TI calculator help. Do I not have it anymore? TI tutorials. So if you have a TI calculator, you can actually get the 5-number summary, TI help. So you can do this stuff on the TI calculator, which is perfectly fine to do it on, entering in the values under the list and doing the 5-number summary. So if you want to do this via the TI calculator, definitely check it out. Here's how to do it with jump. It's a long question, so I'll send it in 2 pieces once you're done. Awesome. Yeah, definitely. And so we'll do that. We'll be done here in about 5:10. So yeah, thank you, Lindsay. Great job. So Lindsay, 50 points. I like it, hanging out. So we're going to go here and we're going to copy the data. So we're going to copy to clipboard, and then we're going to hit Control Command C. Then we're going to go inside of jump. So all we did was copy it. I'll show it again. Copy to clipboard, Control Command C. And now we go to jump. And inside of jump, we're going to go to File, New Data Table. You're welcome, Tiffany. Congrats, Tiffany. Great job. Keep getting those hundreds. Keep getting those hundreds. Show up here, hashtag show up, get those hundreds, and then work on the quiz, get the 100 on the quiz. So with the data table now open, we're going to go right here and go to Edit, Paste, and just paste it in. It does not have column names. Now that we've pasted it in, we have the data. Here's what we can do right now. We're going to go here and right-click and go to Sort and Sort Descending. We'll take a look at this here in a moment. But another thing we can do, hey, what's up, Herschel? Good to see you. We're going to go here to Distribution, and we're going to double-click Column. Did you just get done with an internship, Herschel? Congrats, so you don't have to say it, but I'm thinking like all the LinkedIn stuff I see. We're going to go to, let me show it again. I was talking over that. We're going to go to Analyze Distribution, and this will let us see the distribution of the quantitative data. And then we're going to double-click Column 1, and we'll click OK. And then we'll click the top red arrow, and we'll stack it right here. So now we can see the distribution of the quantitative data. And this is your visualization too. You'll be doing something like this. So if you notice, we get a lot of the answers right here. Yes, that's what it is. Yeah, they're going to be coming back and speaking to us in September. So they're coming back and speaking. And I remember, yeah, you got that. And I think it's because they came and spoke to us last year. I still need those birthday cake flavored Cheetos. I'm going to tell them that. They're going to hear, I'm going to be like, you know, I'm just saying, you got some birthday cake flavored Cheetos. You're holding out. I'm eating healthy now. But you can get me back on the junk food bandwagon by sending me those birthday cake flavored Cheetos. So this is a distribution of quantitative data right here. We see right here the mean, which is the average of all the observations, the standard deviation, which is a measure of spread, the median, which is the 50th percentile, and the IQR, which is the range between Q1 and Q3. Can anyone right now for 50 points calculate the IQR? Who knows what the IQR is, which is just the distance these two numbers are apart. The IQR is just like an inner range of the data. It's not the full range from the biggest number to the smallest number. It's the range from Q1 to Q3. So it's just how far are these numbers apart? Yeah. We got some 320 next, Herschel. But yeah. I can definitely help with that. I know, it sounds so good. Who knows what the IQR is for this? See if you can calculate the IQR right now. Remember, it's just the range of the middle 50%, and range is just big number minus small number. Well, how do you find it then? 11, Jillian, another 20 points. Great job, Jillian. Another 20 points. The range is just, or the IQR is just the range of the middle 50%. Does that make sense right there? It's just how far is Q3 from Q1? It's just the distance these two numbers are away. Sorry, I'm getting all choked up from this. And so with this right here, we've got a lot of our answers on the screen. We can basically find out. Miriam, great job right there. And so the median, here we'll do this. Can we get it all on one screen? Yes, we can. And here we are. We don't need those extra things. So the median is 44. Awesome. The lower quartile is the 25th percentile. So that's the lower quartile. The upper quartile is 47, which is the 75th percentile. And that's it for that one. Wow. Owen Wilson, what do you think?
Wow.
That's what he always thinks. So now this problem is deceptively harder because for some reason JUMP calculates numbers a little bit differently. Let's go ahead and do it the same way, but make sure we get it right. We're going to go right here and copy the numbers. Can we do the content quiz? Yeah. Our Monday, I think, is still... Yeah. I think we did... Yeah. We'll do that. We've done it in a different video. We'll put that in the list, Saeed. You got it. And yeah, maybe I'll put it on Tuesday or something. Maybe I'll put it to Tuesday. So that way we can cover it on Monday. Like, we'll cover all the material. But we'll definitely do that. Yeah, I think I'll put it to Tuesday. Let me change that after this. Copy to clipboard. We're going to copy the numbers. And we've copied the numbers now. Let's go ahead and take the data, open up a new data sheet right here, File, New Data Table. We're in Jump, File, New Data Table. We've got our data copied. We're going to go right here. It keeps appearing on my other screen. And we're going to go here to Edit, Paste. And once we paste in the data, we're going to sort it. And this is just going to help us better see the values of the numbers. Now, when you look at this data right here, there's 10 observations. Can anyone tell me the median of this data right now? I just want you to look at this data, and all I want you to do is tell me the median of this data. I know it's not asking that right now, but I just want you to look at it and tell me the median of this data. With 10 numbers going from lowest to highest, there's no middle number. So we don't have a middle number because there's 5 lower numbers and 5 upper numbers. So what is the median? With no real middle number, the median would thus be what? I'm kind of hovering over it, but not really. So what would the median, which is not what it's asking right now, what would the median of this data be? Super thing for 20 points. It's not the question it's currently asking, though. The median of this data would be what? 875. Great job, Tiffany, right there. Great job, everybody. Oh, I think I'm on top chat. Let me go to live chat. Okay, that's going to make it quicker. Great job. And Zaid, that's worth 50 points. Zaid is showing the mathematics, averaging together the two middle numbers. Sorry, YouTube by default goes to live chat. I have to change it to, top chat. I have to change it to live chat. Technical stuff on my side. Let's go ahead and find the mean of this. You could pull out your calculator, add them all up, divide by 10. That works. Or you can go to analyze, distribute. You know what? Let's do it like it's a test. If this was a test, we'd have to take out our calculator. Be very careful. 350 plus 1250 plus 1200 plus 1150 plus 900 plus 850 plus 800 plus 750. I'm going to make an error. And now we divide by 10, which is 960. So the mean is 960, which is the average. Now the range, or the median, is the middle number, and there's no middle number, as we were saying, so we average together the two. And now Q1 is usually where people get stuck on this one. Huge disclaimer. I need like blaring things on the screen, like disclaimer, disclaimer, disclaimer. If you do this via analyze distribution, you will get the wrong answer. It's just the way that Jump calculates it. I need to find out how to make Jump calculate it differently, and it drives me crazy that for some reason the way Jump calculates Q1 and Q3, there's different ways statisticians have done to calculate it, and Jump actually calculates it a way that causes an issue. And I'm trying to see if we can get it over here maybe in a different way, but it drives me crazy that it just doesn't do it the same way my Pearson does it. So instead of using that information, all we're going to do is look at this. What is the middle number of the top 50%? What is the middle number of the lower 50%? 20 points on the line here. What is the middle number, which is Q1? What is the middle number of the lower 50%? Like if you take the bottom portion of the data and you find the middle of it. Well, that's the middle of the bottom portion of data, so that's Q1 right there. Because we're just taking the bottom half and finding where the 25th percentile is. 750, yep. And this is the way to ace this question. We don't like asking Q1 and Q3 questions on the test. We'd more often ask you through looking at the Jump output. The top is going to be 1200. And what does that make the IQR? I think it might ask me, what is the IQR? It asks what the ranges are. The range is going to be the biggest number minus the smallest number. So the biggest number is 1350. The smallest is 650. So 1350 minus 650, 700. And then does it ask the IQR next, I think? And the IQR, who can solve the IQR mathematically? Show the IQR on the screen for 20 points. Solve for me mathematically the IQR. Who knows mathematically? Remember, it's the same sort of idea, but you're going to take the big number of Q3 minus the small number of Q1 to find the range of these two numbers. How far are those two numbers apart? Just like max minus min is the range, we're just going to do big number minus small number is the IQR. So the IQR of right here, big number minus small number, just their difference. What is that going to be? Great job right there, Griffin. I don't think we've seen from Griffin today. Griffin, there, right there, that's 50 points. Griffin, thank you for joining in the chat. Oh, I think Griffin had another response. Griffin, great job. There you go. And we have now aced the assignment. We got one wrong. Not today, my Pearson. I do want to show the notes on this. We talked through some notes a day or two ago on this, and here's our notes. So we've gone a little more in depth, at least talking about this during office hours. We will go through it in class, and I will do drawings like this in class. The IQR is the interquarters representing 50% of the data. It goes from Q1, as in 1 quarter, all the way up to the 3rd quarter, and it's the middle quarters and their range. It's just like the range of the data, but instead of going from the minimum value to the maximum value, you would go from Q1 to Q3 because it's the interquarters range, not the range of the full data, but the interquarters range, going from Q1 to Q3. Thus, the formula is big number minus small number, like the range is big number minus small number. And it's just a distance two things are apart. So hopefully just pause here, try to practice, and we will be covering this in class. So once again, remember, this is something we will be doing very shortly. And if you're learning it now, you're way ahead of the game. I think we're going to do a 320 question right now, right? Go ahead and put the 320 question in the chat. I'll hop over to a different break. Let's do it. That was some good work right there. Good stuff. Excellent work. If you're practicing along, that's what you need to do. Just practice along. I got to get new headphones. My headphones make me fear I'm going deaf. It's not a good thing to say, right? I'm already blind. Not literally, but I've had 2 eye surgeries. So hopefully I'm not going deaf. Oh, awesome, Zaid. Glad you like it right there. It's all about practice. It's all about practice. Practice. We're just here to practice, learn the material, and the more attempts we get at it, the better we do. All right, so we do. Yeah, what question on activity 1? Let me pull back up activity 1 from last night. We've got the notes from last night. And where is it? Where is activity 1? Here we go. I've got the notes from last night, yeah. We'll do, and then what did people for 201 want to do next? I think there was more 201 questions. Oh, and Herschel had a question. So put your questions in the chat. I'll try to do as many as I can. I just really don't understand, but when I look at one of my questions, use a table and find out how often the industry shoe stores appears, but I can't find where it would appear on the sheet. Ah, yes. Let's take a look. Okay. So let's go take a look at that right here. And so for this one, I'm going to pull it up here in a second so you can see. Let's go take a look at activity 1 for 320. Here we go. Yep, Tiffany, we can start doing that next. I think Herschel's question is next. So you need to load in the data first. So make sure you have your data loaded in currently. We might have to take a look on Discord, Herschel. We might have to take a look. So do you see right here, does this run for you, Lindsay, right here? Does that run and create the customer data frame? So you should have this code right here. It should be hashtagged out, and hashtag makes it a comment. So we're going to unhashtag it. It's no longer a comment. Comments are just whatever you want to write, like this is a comment. Comments are not codes. It actually went down and ran the next code, but comments are not code. I thought I did right. Could you go through it again? Yeah. So make sure, do you see this appearing right here? This is the brain of R up here. R knows what customers are right now. Customers is a data frame. Customers has inside of it vectors, and this all looks like an Excel spreadsheet. So do you have this right here where it says cust right here? And if you run this line where we have right here this, if this appears, oh, you do not. Try running this code right here in the bottom console, like take it and put it right there. So that code I just put in the chat, put it in the bottom console and go ahead and run it and tell me what it does. Does it make it appear, or does it give you the following error right here? Does it give you this error right here? I'm guessing it gives you an error like this, right? I'm guessing this is what appears. If this is what appears, because this is an error it would probably give if it's not running. We'll see if we can confirm this is the error. Something very close to this right here. Where it says like error in file cannot open the connection. And then we'll explain what this error means. Given that this is the error, because if it's not appearing, this is the most likely error. This error, yep. So this error right here means your file is not in your working directory. Make sure, let's go take a look. Go to the activity. So let's go over to the activity right here. And in the activity, make sure error attempt to use 0. Is that when you run the following code? That's a different error. When you run this code, it gives you a 0 length vector. Like only run this code right here, down here in the bottom. Like have this right here, copy paste this into your console and just hit enter right there. And then that says 0 length vector. Zero length variable name has a different error. Double check this. Here, I'll give you some stuff to double check right here. We want to make sure that we have the data downloaded. So we want to go over here to the assignments, and we want to make sure we have the data downloaded. Is it working right now, or is it... Let's go over here to the activity, RBasics. And in the RBasics activity, make sure... Save those changes. So I'll try it again. Yep. Make sure you have all of this downloaded right now in your working directory. You won't have the solutions yet, but make sure you have the Act1 cust trans data right here in your working directory. How's it looking with that right there, Lindsay? Is this in your working directory? Download it and save it to your 320 folder. Like go ahead and download it here, and then make sure you put this in your 320 folder. So with everything in your 320 folder, it should work. You'll just kind of download it, go to your like show your files over here, and then just make sure you drop it into your 320 folder. Like wherever you have your 320 folder. Yep, 100% recorded, Alex. So feel free to ask a question. We're probably going to do some quiz 2 after this, I think. I might try to look at Herschel's problem, but 100% recorded. So you can come back, and I even put the timestamps in these afterwards. So you can check out the office hours afterwards, and they will have timestamps. Here, I'll just show real quick. Office hours from yesterday right here. Oops. Here's yesterday's office hours. And if you notice right here, it's got timestamps for what we cover. And you can go down here and just click a random thing, and you'll be right into the timestamp for what we're doing right there. So you can just be like, oh, I really want to check this portion out and work this. And so now I want you to do this. Make sure your tools, global options. Hey, Mohammed, good to see you here. Make sure your global options, go to tools, global options. And under global options, make sure you have your 320 folder as your working directory. So make sure your 320 folder is your working directory, and then click apply, and then OK. How's everything looking right there? We might need to hop on a call with this. Can you go over how to start the file for the visualization on a Mac and how to get a document for my files? Which one, Eleanor? Yeah. And how's it looking, Lindsay? Working, not working? We might have to meet on it if it's still not working. Do we have to submit the RMD along with the Lab 1 quiz? Nope. You're welcome, Alex. Great job. Just the quiz questions. We just have to answer the quiz questions. You got all those steps. Then what I would do is I'd restart R. I would close out of R. I'd close out of R, and then I'd restart my R, and it should start with the working directory right here. So I'd restart my R, and you should be in your working directory now. And then I'd go ahead and run this, and it should run. Tell me, I just speed ran quiz 1. Nice job right there, Griffin. Hey, Griffin gets some 50 points right there. I like that right there. Griffin's speed running the quizzes right there. Hope you got 100 on it. How's it? Is it working now, Lindsay? How's it doing? And Herschel, are you still here? Did you put your problem in the chat, Herschel? We'll do Herschel's next. I'm trying to hit my assignment in Word, but it prompts me to install updates to packages. From then, I'm getting many red errors. A lot of times the red things it's installing. It might have a problem with installing one package. Look to see if it says something like had non-zero exits down here, and we might have to meet on Discord. Does it matter where I put when you run it up here, hit Control-Enter. So try running this right here. Does that make sense? I'm just running it a few times. Like to double check? Yep, we can do that next thing. We're going to do a 201 after this. And then, Mohammed, we can do that. 3C, I think, did we do? Yeah, we can do some 3C. So does this make sense right here? How's it looking, Lindsay? Yeah, to non-zero. Yeah, and then so if you get a non-zero exit error, go to install.packages. And maybe it's like HTML tools or something. Try doing that, like install.packages. Lindsay, do you have the Discord, Lindsay? Or can you send me a screenshot of what you're seeing? We'll try to solve this a little bit more right here. Can you send me a screenshot of what you're seeing? Like send it to me via email or Discord, a screenshot of what you're seeing. Like take a screenshot of your full screen. Like use snipping tool or Command-Shift-4 and take a screenshot of everything you see. Like send me a screenshot like this right here. So best like snipping tool or Command-Shift-4. A lot of people say, I'll get so many like phone screenshots of like, no, just snipping tool, Command-Shift-4, really quick and easy to see. I'll try to diagnose from there. And Herschel, can you have most of the console pulled up, Herschel? If you can send me, we'll do more 201 here in a second, then we'll do Mohammed's question. Can you send me a full screenshot? I'm going to go to the main screen. So let me see if I can figure out these problems right here. Okay. Let's see. I need to start sending these. I get random emails. I need to send them to spam. Like consistently send them to spam. Put on a little chill music right here. And let's see. Seeing people are sending it. If you tell me when it's sent, I'll take a look right here. And then we'll do... So 201, should we do visualization or quiz? What does 201 want to do? 201 visualization or quiz. We'll be doing that next here. So 201 visualization or quiz in Herschel. And I think I see... Wait, is that... Here's Lindsay's. Okay. It looks like... Wait, is this yours, Lindsay? It looks like Lindsay... Wait, no, it loaded, Lindsay. It's up there in the corner. Yeah, you got it. It's good to go. It looks like you're running something else. You're running the portion of the chunk, but it looks like it's got it. You only want to run... Oh, you have it outside the chunk area. I see it. Can I show this on the screen, Lindsay? Say show it on the screen, and I'll kind of talk over it a little bit here. If you say I can show it on the screen, I'll show it on the screen. If you say show it on the screen, just say show it on the screen, and I'll show it on the screen. If you say I can do that. I'm getting it arranged so I can kind of talk through it a little bit here. If you say show it on the screen, I'll be like, okay. Getting this set up here. As long as I have your permission to show it on the screen. Say show it on the screen. Okay. Let me take a look. And stop. Sorry, missing things. Show it on the screen. Got it. Let's do it. Here we go. Okay. So thank you, Lindsay. Okay. So this right here, and great job, Lindsay. Lindsay, I'm throwing you 50 points. Don't worry, a lot of people are going to make this error. This right here is in the word portion, not in the coding chunk portion. So this needs to go inside of a code chunk right here. Does that make sense right there, Lindsay? Like, hey, Ryan, good to see you here. Visualization? Yeah, I would use just one screenshot. Great question there, Ryan. I'd use just one screenshot. Thank you, Ryan, so much. Ryan, 20 points right there. Thank you for asking that. This needs to be in this portion, but it is loaded up. Notice that you do have it loaded up right here. So it is currently loaded. Does that make sense, Lindsay, right there? Like, it is loaded in. And then we can take a look at it, and we can actually figure out what column a certain vector is inside of. So make sure the code are inside of code portions. I think you're Harry, right, on there? Is that your name on Discord? It should be inside of here. It shouldn't be after. You could delete these comments. It has to be inside of a coding chunk. Here, I'll show what it looks like. It has to be inside of this. So you don't want it outside of it, like down here. You want it inside of these code chunks. Good question there, Lindsay. You're welcome, Ryan. Excellent work. And you can send it to me to look over it. If you're like, hey, Brian, can you just double check this? I'll give it a double check. So make sure it's inside the coding chunk. And then it is currently loaded. It looks like you were trying to run the end of the chunk. We don't run these portions right here. That's not code. This is where your code ran correctly right here. This ran correctly. This was the coding chunk ending, which we don't usually run. And that's where you're getting an error right there. That's just like the end of a chunk. We don't run that, or the start of a chunk. So that's what it's giving right there. So these are not portions we run. It initiates a chunk. So if you destroy this, like watch, it destroys the chunk. So this makes code right here. It says like, I am coding in this area by doing backtick, backtick, backtick. If you destroy this, it destroys the end of the chunk. So we don't usually run these portions right here. We run the code inside of the chunk. But you've got it right here. It looks good. It is loaded in your data frame. And then this was the end of just chunk being attempted to run. And we don't have any packages to install. So don't worry about that. Lindsay, going out on a limb here, sending your code, 50 points for the whole class. Thank you, Lindsay, for sending this for us to go over and kind of talking about some ideas for this. But with this open, I think you were asking about one of the vectors, right? So can you tell me, I think you were asking about super industry was or something like that. What column number has super industry in it? Or industry? Well, let's do super industry first, then we'll look at Herschel's next. What column number has super industry in it? 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 Oh, is it, what about shoe stores is the question? What question did I write here? Can you repeat the whole question? Now we've got the data loaded up. Can you repeat the whole question? And I'll go through the question. I have both industry, but so what does the question say again? Let me go grab it. The question was, I don't really understand how to do it, but when I look at one of the questions, use a table to find out how many often the industry shoe stores appear. Ah, okay, got it. How often do shoe stores appear? So we want to go to the data frame cust, which is customers. And how do we go inside of it? Herschel, Lindsay, this is good practice. How do we go inside of a data frame? How do we go inside of a data frame? So how do we get inside of a data frame and use the vectors, which are just kind of like an Excel spreadsheet? How do we go inside of a data frame and get the vectors inside of it? How do we do that? How would we reach inside of a data frame and get the vectors? There's a hint over here on the screen. And once we type it, it'll start auto-completing for us. How do we reach inside of this data frame? How do we connect data frames to variables? Exactly, Herschel. Great job. Great job, Herschel. We'll throw some 20 points right here. So we are going to choose industry, and it auto-completes for us. And if you notice, we get all the different industries, but we want to only find shoe stores. So I'm going to highlight this code. Great job, Herschel. And now we're going to go here, and we're going to go and type table. And guess what? We've done it. We can scroll up and we can see shoe stores, and the answer should be 6. Tell me if it's not. But it should be shoe stores. You can also do summary, and it'll also give you a summary. Oh, that's characters. Ooh, we don't want that. We want a table. So we want to use table, not summary. If it was a factor, we could do it. And this is just another version of it, but as a factor. So we'd have to turn it into a factor, and we can make a table of the factor and get the same result. Does this make sense right here, Lindsay, that we have right here a vector, and then we're just saying put it into a table and summarize the results for us. For Stat 201, I will throw 100 points if Stat 201 knows what this is. Stat 201, if you're listening in, we're about to start your questions. Stat 201, tell them, Brian, you just made a this. Hint, it has the counts of the observations. Stat 201, 100 points online right here. We just made a what? Starts with an F before it. Good practice for all classes. Like, oh, that's just a blank table. So this is one of the ways to display categorical data. One of the ways we covered yesterday is with a blank table. I'm going to look at Herschel's question right here while they think that over. And Herschel, wow, this is crazy. Okay, I'm looking at Herschel's error configuration with string I. People have actually been saying string I has been having a problem. Oh, and then you installed a package of string I? I think so. Okay, wait, warning installed a package that had non-zero exits. Herschel, we might have to hop on a call for this. Yeah, we might have to like. Wow, this is craziness. We might have to hop on a call, Herschel. Frequency table, Tiffany, 100 points right there. You're exactly right. That is a frequency table. Yep. Univariate categorical frequency table. This is just a frequency table, and we're just doing it by making a table. You could make it into a relative frequency table by dividing by the length, which we're not doing right here, but we could. The answer to the question was 6. And Herschel, I think we'll top on. Yeah. Yep. And so this is a relative frequency table. And then we can do it out of 100% by doing the following. Ooh, I think I made an error. There we go. Now, oh. That is not correct. Oh, no, it's just so small. Yeah, it is correct, I think. I think it's just so small. There's a lot of very, very small percentages right there. So as a relative, great job, Zaid and everybody. Yeah, Tiffany, great job. Awesome work. Would I do the same thing with finding a distance equal to 0? So for distances equal to 0, if you want to find out which ones have distance equal to 0, we need to do a logical test on the customers. We need to go here and ask what is their distance, and then the distances can be found here. Now we could count up everybody with a distance equal to 0, but you know what? You are correct. We could actually do this with a table. And with a table, you can see how many customers had a distance equal to 0. Is it 422? I guess it is, right? Or you could solve it the same way by going here and finding out if customers have a distance equal to 0, and also then finding the sum of it. I'm going to pause here and explain what I just did and what's very important about this. Trues and falses, and here's a huge note to take. When you see trues and falses in R, how does R see trues and falses? Then we're going to do 201 right after this. How does R see trues and falses? Like, why was I able to sum them up? R sees a true as a what, and R sees a false as a what. 20 points on the line here. It's because I can sum them up because R just sees a true as a this and a false as a this. Very important note on this. R sees trues and falses as whats and whatses. And it'll make more sense maybe if I do this. What is the sum of true plus true? R just sees trues and falses as whats and whats. R sees trues and falses as just if it's a true, R sees it as a what in the background. If it's a false, R sees it as what? 1 and 0, ones and zeros. R sees it as ones and zeros. So if you have a vector right here, you could find out how many trues are in it. Like here's a vector, and we could find out how many trues are in it. Like let's say there's a whole bunch of trues and falses. You could find out how many trues are in it just by summing it up, and there's 10 trues inside of it. Oh, no worries, Herschel, right there. Herschel, 50 points, Herschel. Great job, everybody. This is the practice we need. Was the answer the one in the... Oh, it should be both of them. This one right here works. You have to look, though, at this. That's how many people have a distance of 0. And then this one gets you the direct answer right there. You could also take your table, and you might be able to do this. Ooh, we can't do that. Can we do this? There we go. We can go to position 0 of the table because it's a named vector. So these are people who had a distance of 0, and then this was doing a logical test to see what if people had a distance of 0 and summing them up. Awesome, yeah. Are you message me on Discord? I can probably do it right after 475, or maybe between office hours and 475. How much time do I have between that? Today's a busy day. Yeah, Herschel, if you are free at 4:15 your time, we might be able to hop on. So I think we're going to do quiz 2 now, right? We're going to do quiz 2. Put a break in the video. You ready? Let's go do it. 201. Is it time for some quiz 2, 201? Oh, what's your other question, Lindsay? What other question were you wondering about? We're going to hop back to some... I can't even speak. We're going to hop back to some 201 for a bit right here. 201. I think they wanted quiz number 2. Let's take a look. 201. Quiz 2. Matt Pearson had to change their whole thing. Ooh, we got lots of questions here. So we'll do some questions. Is there a specific question people wanted on quiz 2? What question did people want? Oh, changed it. Oh, cool. What question did people want? Maybe I'll do some tough ones right here. Visualization? Which visualization do people want? I just need to see how row 28 define the amount spent on the transaction. Click the data set and take a look. Click the data set and take a look. How do you do the screenshot, the whole visualization table? You do screenshot your whole table. If you want, send me your screenshot and I can double check. If you want me to say like, hey Brian, did I do the assignment right? Send it to me, I'll double check. Especially for the first one, be like, is this correct? Did I put my name? Did I put the screenshot? Did I have the right sample size? Send it to me. I'll double check for you. Question number 2. Your question number 2 is probably different than mine, Tiffany. So send me real quick the start of it, because everyone's quizzes are different. So which one do you want to do, Tiffany? What's your question 2 say? So, because question 2 is different for everybody every time you take it. How does your question 2 start? And I will then start that question 2. I got a bunch of sleep last night. I was still tired. Need more coffee. Coffee's out. It's the doctor coffee. Spilled a little bit of coffee today. Says, trust me, I'm a doctor. 2 research measured the pH. Let's check it out. So I'm going to go find this. You'll see it'll be different on mine. It won't be question 2. Watch it be question 2. That'd be really sad. Like, I told you it was question 2. There we go. Looks like it's going to be a way different question for me. 2 research. For me, it's question 18. Let's go check it out. Oh, yeah, no, Griffin, you're totally fine. Griffin, great question right there. You only need to fit... no, like if you fit 20-something on the screen, you're fine. I when I do my screenshots, I do 20-something. Yeah, no, great question, Griffin. You only need to fit like 20-something. I might still have... do I still have like one of those diamond subsets up? Yours will look something... It'll have... It'll look something like this right here. It'll look like this right here. So when you take your screenshot, it'll look something like this. I was taking this screenshot a few days ago. So here we go. 2 researchers measure the pH on a scale, which is a value of 7, which is neutral, yada, yada, yada. pH, fun stuff. Describe their data with a graph in a few sentences. Okay, so 42-5 means 4.25. So we got to be very careful right here. You're welcome, Griffin. You're welcome. Awesome work there. Keep it up. Great job on the visualizations. So the highest number in this data set looks to be 5.19. Oh, well, dang, it's there in all of them. We see differences right here on the 49. So 4.9. I see 4.99. Oh, look. Okay. So 4.99 exists. Which of these answers must it be between now? 4.99 exists. So which of these answers is it going to be? Could it be A, B, C, or D? Remember, 4.99 exists. And we have to know how to read this. 42-5 means 4.25. So what answers are possible right answers right now? Because 4.99 exists. So I should see 49-9. What is a possible answer on this? There's only 2 answers that work now. So which 2 are possible answers right now? C and D. Miriam, great job right there. 20 points. C and D are possible answers now because 499 is this. Remember, we have to read the key when we look at a stem and leaf. And so C and D are the possible answers. So if we see 51 up or 5.01, which we do, boom, its answer is C.
Wow.
Thank you, Owen Wilson. 5.01 is 50.1, and we should see 5.06 just to confirm. Where you at? There you are. So that does confirm it is C. Now, this one's a bit tricky. This has got the trick we saw earlier. And let's remember what trick we saw. We want to know the shape of this. Now, a lot of people are going to be like, aha, it's left skew. But no. Don't be tricked. Remember our saying, right to the high, left to the low. Whatever way the what goes. What is it? Put in the chat for 20 points. Right to the high, left to the low. Whatever way the what goes. Now you'd say, well, Brian, it looks like that thing is going to the left, but the number line is reversed. These are the big numbers. These are the small ones. When you have number lines, you need to go from low to high. Yes, tail goes right there. Great job. And so we're reversing it. And I know this has kind of made the graphic look all crazy here, but now we can actually do right to the high, left to the low, whatever way the tail goes. We draw our little monster man on here. There's the monster man, and here's his monster man tail. So now we can see right here, it is right skew. This is a right skew distribution, and if you look, just remember right to the high, left to the low, the tail is going to the higher numbers. If you plop it down this way, it is reverse number line, so don't be tricked. It is right skew. So this is right skew, and possibly bimodal, sure. All I care really about is that right skew, And, oh, we got a check answer. Yes. Awesome. Let's try to do 2 or 3 more here. That's got this one, identifying how to read a stem and leaf, taking the numbers, translating it, looking at the key, also identifying skew, not getting tricked by, remember, right to the high, left to the low, whatever way that tail goes. Let's throw another one on here. Pick another question. Pick another question to do. You got it. That one was a good one right there. I like it. What is another 201 question? Name off the question and say, hey, Brian, can you work? I'm gone. Ah. What is another 201 question you'd like to work? Just put the start of the question and we'll work on it. We will solve the question. Will you go through this on Monday because I'm not understanding anything? Yes. We started stem and leaf at the very end of class on last class. And then we're going to do more stem and leaf at the start. And this assignment is not due until... When's this assignment due? This assignment is not due until Chapter 2 quiz. It's not due until Tuesday. So we'll be going through it on Monday very in depth, and it's not due until Tuesday then. So you will have a day to cover it in class. The histogram on the right shows the next sizes. You got it. Let's do it. And if you're not understanding any of it, don't worry. We will be doing it. The leaf, August 31. Do you want to do that one next? Shows the number home run. The leaf, August 31. Next sizes. Here we go. Let's take a look. Next size histogram 1 for 201. Let's check it out. This one's a little bit tricky. What we have right here is the data is unimodal symmetric, and we would thus use the mean and the standard deviation to measure it. So please note right here we're using the mean and the standard deviation. And I want you to put this word in the chat because the data mostly looks what at this point? How does the data mostly look? Unimodal symmetric, and we call this curve the what curve? What you should never aspire to be. It's all right if you're this. What fun is being this, though? No one should want to be this. Be fun, be interesting, be you. Centered, well, it's a good job right there, Tiffany, 20 points. Normal data. Someone called this the normal curve, the Gaussian curve, the bell-shaped curve, all those terms used for it. We call this the normal curve. So if you look at the shape of this right here, we're going to use the mean and the standard deviation based on the shape right here for univariate quantitative data. So here's the normal curve up here, a little bit of outlier, I don't know, a little low. And so with this right here, the mean is going to be towards the center. It's not skewed in any direction. So the mean is closest to 15 because it's the balancing point. Now this is tricky. Why? What's the difference? This is actually talking about the median right here. When it says it splits the histogram into 2 equal parts, the median would split it into 2 equal parts because it's the 50th percentile. The mean is going to be the balancing point when we average everything together. So this terminology right here, because it splits it into 2 equal parts, is a better terminology for the median, where this over here, because it's the balancing point, is better terminology for the mean. Now, the hard question a lot of times down here is the standard deviation. But I want you to check this out. I can basically remake this right here. Watch. I'm going to go here into R and remake this for you by going here and going to histogram of random normal numbers. And in my random normal numbers, I'm going to make 1,000 random normal numbers with the mean of 15 and a standard deviation of 1. Oh, we got to make the figure margin a little wider. And I'll explain how I knew this. And look, it looks very close to what you see on the screen. What I've created down here looks a lot like, from 12 to 18, what you see currently here. And I know something about this, that when we have data, almost all the data will be within how many standard deviations of the mean? 30 points in the chat, hint, hint. That's not the answer, though. Almost all the data will be within how many standard deviations of the mean? So notice here we're at 15, and if the standard deviation is 1, pretty much all the data will be within how much standard deviations of the mean? If you go out this many standard deviations, if the standard deviation is 1 right here, pretty much all the data will be within how many standard deviations of the mean? Pretty much all the data will be within how many standard deviations of the mean? Great note to take. And it's technically 99.7% will be within 3 standard deviations of the mean. Exactly. Now I want to point something out right here. What if I told you that test scores are normally distributed with a mean of, let's say, 80 and a standard deviation of 5? You would expect pretty much all the test scores to be between what and what. And it might not look perfectly like this, but almost all the test scores, I'm going to make it 100, almost all the test scores, think 3 standard deviations below, 3 standard deviations up, pretty much all the test scores would be between this and this. So remember, here's the mean, that's going to go at the center, and here's the standard deviation, that's how much we're going to go down each time, and pretty much all the test scores would be between a low of this, 3 standard deviations down, and a high of this, 3 standard deviations up. Excluding outliers, we'd expect people generally to make between a what and a what on this test. 3 standard deviations down would be 15 down. 3 standard deviations up would be 15 up. So we'd expect the scores to generally be between, with 3 standard deviations below and 3 standard deviations above. Normally distributed data. Great job right there, Tiffany. You are correct. Oh, what am I doing? It says unexpected symbol. Oh, no. There we go. Wow. And there you go. That's got it right there. Tiffany, 50 points. Thank you for following along right here, Tiffany, with all these examples. And Zaid, great job. Does that make sense that we generally expect... Sorry, everybody. We generally expect scores to be within 3 standard deviations above or below the mean. If you did something like this on an organic chem test, we'd expect scores to be between about 20 to 80. And you can see right here, 3 standard deviations. Does that make sense how I knew that if you go down 3 standard deviations, that we should have pretty much all the data? So the standard deviations here look to be 10. You can't always look at the scale on the bottom. It's not promised to you that the scale will have it, because I could do something like this. And now the scale on the bottom, it breaks. There we go. The scale on the bottom is not actually the standard deviations right now. Or it still is, actually. That's interesting. Here, we'll go and do something even crazier. No, it still is. Well, I'll be. Oh, you know what I could do? I could go here and do this. I could go xlim and do this. Concatenate 0, 100. There you go. Now it's totally different. So it's always 3 times. On normally distributed data, we generally expect from the mean 99.7% of the data, and this is a little bit of chapter 5, but this basic concept's used right now. If you go down 3 standard deviations, that's pretty much all the data. I've made this look very, very crazy. It should look something more like this right here. Remember how we can change bin widths? This is just a change of the bin widths right here, making the data look a lot different. It's still randomly simulated data from the same results, but here we have different bin widths, very, very tiny bin widths. So that's a review of what we were covering in class when you can change the bin widths to change the way a histogram looks. And I am actually simulating different data, but it's still the same idea that we're changing the bin widths. Does this make sense right here? That we know that it's 3 standard deviations because pretty much all the data is contained within 3 standard deviations. If the standard deviation was 5, it would go down to 10, 5, and 0, which is not how it's contained. And that's got it. Can you also do this problem quiz? Yeah, let's do 1 or 2 more here. We got enough time. No, we'll try to do, I think, Mohammed had a question. We'll try to do that here. Can you just question in education, statistics report, mathematics, achievement scores of 8th graders? Yeah, let's do that one right here. 8th grader scores. Where's the 8th grader scores? Here we go. Let's go do it. Time to do it. Let's check it out. And jumping into the question. So this question right here is best done in jump. This is a jump question right here. Hey, Trevor, do you go over the Canvas content quiz? Yeah. We could probably do that next, right? We could do a version of the Canvas content next. And I'm going to move mine back to Tuesday, I think, to give everyone a little more time. But I would definitely be attempting it. A lot of people have aced it so far. I think we do that next year. I think we try to do Muhammad's question too, and then we'll do the Canvas content. So this question, we want to copy it to clipboard. And so you're welcome, Trevor, anytime. We're just going to hit copy, 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 Controller, Command C. And then we're going to go to a new worksheet inside of Jump, File, New Data Table. File, New Data Table. Did you have a problem before? Which one is that again? I think we did some during class today. Might have to put in the chat, Cora. And so let's go to Edit, Paste, and we're pasting in the data. This is not what I would solve by hand, and this is not a really fun one to enter into your calculator. Now, when we do the 5-number summary here, we're going to go to Analyze Distribution. Analyze Distribution in Jump will let you analyze univariate data. We're going to double-click column 1 right here, and there we go. It'll analyze it for us. This is actually your second visualization assignment to make histograms. Now, if you notice, we want to put it in horizontal layout by going to the red arrow and going to Stack. There we go. And this is a very weird distribution. It's got that bump over here on the side. And I think I better like those quantiles. That's what I'm saying. So let's go ahead and... Is this one of the ones that's going to be weird? I eliminated some questions for my summer class, and I need to tell Terry we might need to eliminate some of these. We're going to cross our fingers and make sure... Is this one of the weird questions? This quantile looks a little bit odd to me. And I don't like it for that reason. No, sir, I don't like it. Let me look at the data. When we look at the data right here, we can actually find... I think this is going to be one of the least fun questions right here. We can find the IQR itself by going here with 22 numbers. We would have here the top portion and the bottom portion. We already have the median, and the median is right here at 439.5. How is the median being found? With the top 50% and the bottom 50%, how is the median being found? Who can tell us mathematically how the median is being found with 22 numbers? Because there is no middle number. How is the median being found? This is another one where you have to not use Jump. I removed this one from my summer class. How is the median being found? Think mathematically how the median is being found. How do we find the median if there's no middle number? Good question right here. There's no middle number. There's 11 numbers, and there's 11 numbers. If you want, double check. Well, that's 11, you can tell. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's no middle number. Great job right there, Tiffany. You are right. We would average together these numbers, and that's how that's being found right there. So Tiffany's got the number for the median in the chat. And so it was 439.5. Now, this is where it gets tricky. The min and the max are easy enough. 273, and the max is 589. Now, here's the thing. If there's 11 lower numbers, then think about this. The number that would be the median of the bottom lower numbers would be what? If you only have these numbers here, let's show only these numbers, then you would count in how many numbers to get the median. And look at that, 6 numbers. So this is kind of a hint for this question. If you count in 6 numbers, you get the median, like 1, 2, 3, 4, 5, 6. And this is Q1. So Q1 is right here at 386. Guess what? We can do the same thing on the top. 1, 2, 3, 4, 5, 6. And that is Q3 right there. Does that make sense right there, Tiffany? That I'm just taking the bottom portion of the numbers, the bottom 50%, and finding like the median of the bottom 50%. And so with this right here, Jump just does a slightly different calculation. It's always drove me nuts. But with this right here, we have the median of the bottom portion of the data. It's the 6th number in. If you did the same thing to the top portion of the data, trying to get it displayed properly, I think it's so hard to get it just perfect on here. There we need, I think it goes that, right? Then you go 1, 2, 3, 4, 5, 6. And that is the median of that right there. That's the median of the top portion. Is that making sense right there? I found like the median of the lower 50%. I found the median of the upper 50%. These are the top 50% of the data, and that's the median. We don't have you find Q1 and Q3 on the test, but software and other things can find it for you. TI Calculator can find it, and TI does it the same way as my Pearson. How's that look? How's everyone doing? All we do is we count in 6 numbers for this one. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there's your median of the upper set. And here's your median down here on the lower set. So I think, yes, I will. Yep. And make sure they are in order. That's a huge thing. Now, the IQR, how can we get the IQR for this? Who knows mathematically how to find the IQR? Remember that the IQR is just a range of the middle 50%, the interquarters, 2 quarters right here, the range of the middle 50%. So we just do big number minus small number. Since it's a range, it's like max minus min, and we just take the distance they are apart. So mathematically, put the mathematics in the chat. I need your help to find this. Mathematically, what do we do? Q3 minus Q1. Perfect answers right there, Saeed. Great answers, and I'll solve it for you. I appreciate you putting that there. 507 minus 386. So it's 121. Q3 minus Q1. The mean is going to be the sum of all these. This is where jump's going to help us out. Don't let jump trick you with the other answers, but the mean is 451.818181. So 4... And if you want to get the mean by hand, add them all up and divide them. Standard deviation is something you should never solve by hand. Standard deviation is a measure of spread of the data. Standard deviation is best used when the data is normal. It also goes along with the mean. That's why in the jump output, when we see the standard deviation, you'll see it right here next to the mean, 86.88. Oh, awesome, Cora. Thank you so much. I appreciate that so much. So I can't remember what I do a lot of times. I'm sorry, I haven't labeled morning office hours yet. I'll label it later tonight. Cora, 50 points for Cora right there. Shout outs to Cora. I appreciate that. Determine if the distribution score is symmetric, skewed, or of the middle 50% of scores. Oh my gosh. It's a weird looking distribution, isn't it? It's weird. Let's go look at that shape again. That's not symmetric. It's skewed, I think. It's got right skew with outliers. This is not a very classical shape of distributions. It's got a weird looking shape. I'm going to change the bins for a moment by going here. And yeah, it's got a bit of a skew. It's got over here. It's a very weird monster man. But the mean is higher than the median, indicating some right skew. So the distribution is skewed because the mean and median are not approximately the same. The mean will follow the skew. And you know what I love? I forgot this about this question. If you're worried about your answers up top, you can check them down here on the bottom. Totally forgot that. But it's got this check down here on the bottom where it literally tells you what is the Q1, what is the Q3, and we got it right there. Did I enter a dollar sign? Ooh, that's going to get a wrong answer. I think we've got it. Woo! Got scared there that we're going to make an error. Whenever I forget it quickly. Yeah, never do standard deviation by hand. It's when we're inside of R, if we need to do standard deviation, like if you give me a bunch of numbers right here and you say, hey, Brian, what's the standard deviation of these numbers? I can just put it inside of standard deviation, and there's the standard deviation of those numbers. You can calculate it to figure out the standard deviation, which is the square root of variance, but no one's going to sit down, like statisticians are not going to sit down and find standard deviation. If I have a data frame right here and I'm working with it, and we have something like this, and I want the standard deviation, I just go here and say, what's the standard deviation? If I want the variance, I can square it, or I could literally just take right here and take the variance of it. This is why we don't, do these things by hand. If I want the quantiles, I can get the 25th percentile. I don't want of the standard deviation. But here's Q1. Here's Q3. And Q3 just changes to 75%. And then I could also get the IQR, which is the distance of those, by going right here and doing this. Oh, IQR needs to be capitalized. But this is why we don't work things by hand. We just let the computer solve it for us, because I don't need to solve the IQR. The computer will solve it for me pretty quickly. And we just need to know what is the IQR and why would we need the IQR and all these things right here. Is that making sense right there, Zaid? Especially when it comes to statistics, we're not about solving problems by hand. We're about using technology and then interpreting and knowing what it means. Like knowing that the standard deviation is a measure of spread of the distribution, like the IQR is a measure of spread, and we use the standard deviation with the mean for normal data. We use the median and the IQR for spread and center, respectively, for skewed data. And that's the important things to know right there. Yep. So we're not about solving things by hand. Like, why solve things by hand? What fun is that? I don't want to sit down and work math equations. I want to write code. I want to like have the computer do all my work for me. And then I can just be like, computer work. Computer says,
I am Mubot.
Computer's not happy about that. We had a few more questions. Let's hop back here to the main. I love it. I love it so much. I almost think like coding's a superpower because it's like you're computer man or something like that. You're not computer man. You're hacker man. Oh, now to do it? That's what you actually are. Is a random question. But 474, are we eventually going to have to complete all this lab like we need to? Nope. Good question right there, Cora. Nope. We just have different practice problems, and the more of it you complete, the better. Just kind of work at your own pace on it. We want you to do as much as you can, as much as you feel need to do, and we just have individual problems. You'll never have to turn in the full lab. So, Cora, great question right there. What other questions did we have? We could do another 201 to finish off. I think, Mohammed, we might have worked the one question if Mohammed's still here. But it's your call, everyone, to ask your questions. I set this up for 201 because we were having problems yesterday. It worked better during class. It worked better during class. I can change that. Can we go over the Canvas content quiz? Yeah, let's do some Canvas content quiz. We broke Zaid. Let's do some Canvas content quiz. Let's get serious here. No more fun. No more fun. Quotes Brian says during class. No more fun. Time to get serious. Let's go do a version of the Canvas content quiz. That was amazing, Trevor says. You just got to have dabs in there, you know, just in case. All right. Let's go set this up. And here we go. Let's go do it. I love this. It's good practice. So it says I can save my quiz and not submit. Yep. I believe you can. Tell me if there's an issue. Tiffany will get it fixed up. All data needs what? All data needs this. Does all data need parameters, which is something we want to understand about a population? Does all data need context? Like helps us understand things? Do all data need statistics, which is something we take and get from a sample? Or variables, which is something like a variable is like hair color, eye color, how old are you? It's a variable. All data needs context. The variable average chocolate rating is a what kind of variable? Would you ask someone how much was the average chocolate rating? What group was the average chocolate rating? Or would you ask someone which one was the average chocolate rating? Hints for probably my Kahoot when we get that up and going. Does this sound like a quantitative amount? Like a quantity of a rating of chocolate? A category, like it would go into a category, a group, or does it identify a certain one right here and it's unique for each one? Quantitative variables are actual real numbers. Are those real numbers? Categorical variables put things into groups, and this is quantitative. Identifiers are unique for each and every one. So company name is probably the identifier. You might say, well, wouldn't company location identify it? You could have two chocolate companies in Peru. So company location is not going to be an identifier. Couldn't you say, well, couldn't two companies have the same name? I guess possibly then we might put Chocolate Alchemist Philly 1 or Chocolate Alchemist Philly 2. Like it's like with two Ghostbuster films, there's now Ghostbusters such and such and Ghostbusters such and such. So we have to make identifiers on them if two things share the same name because then the name does not work as an identifier. A blank is a group of people or items that we want to understand. Mubot's been handling this question lately. Mubot, come in here and help us out. Mubot, that's not Mubot.
Okay. I want to go out and talk to UT students. I'm going to go out and take a sample. From that sample, I will get a statistic by asking them, how much do you weigh? Mubot needs to know this. The average UT student in my sample of 100 weighs, on average, 150. This will help me understand the population and understand the true weight of all UT students. So the group of people or items I want to understand would be the what? A, B, C, or D. What does chat say right now? A, B, C, or D? Remember, I went out and talked to 100 UT students, asked them their weight, and got a sample statistic of their average weight, which helps me understand for all UT students the true weight of all UT students, which is what I want to understand. So the group of people or things I want to understand would be the what? That would be the population. What I want to understand about them is the parameter, which is estimated by a statistic. The way I understand a population is by taking a sample. This is the amount you take, and then this is the information you collect, and this is the information you want to understand for all of them. Mubot, out.
Thank you, Mubot. You're the best. We want to find the mean of this data set. The mean of this data set is taking all the numbers and then adding them up and dividing by how many numbers there are. 18 plus 20 plus 25 plus 30 plus 32 divided by 5. Got it. There we go. Which of the following is a univariate quantitative display of data? I'm going to pause the screen right here and let me show you. Here is a screenshot you need. You don't want this screenshot. You need this screenshot. This screenshot has everything. Univariate quantitative is up there in the top corner, the top left corner in blue. Data or graphics that are 100% quantitative are all blue. Graphics that are 100% all categorical are all green. In the top are the univariate displays because they only have one variable. In the middle of this, right around all these regions down here, are the bivariate displays. We don't do logistic regression in this class, so I X'd it out. But if you're looking for a univariate quantitative display of data, then you want one quantitative variable used, and you have histogram, box plot, stem, and leaf, and dot plot up there in the corner. Let's go ahead and see which option we have down here for this. So we just need to pick the one that applies. Bar chart is categorical, univariate categorical. Mosaic plot is bivariate categorical. Scatter plot is bivariate quantitative, and histogram is the right option. Could have been box plot, dot plot, all that good stuff. And I think that's got it. How are people doing? I have done other versions of this. I think we've gone through most of the questions. Has anyone gotten 100 on this? How are people doing? Yep, histogram. Great job, Zaid, right there. Another 20 points. I think you're following along right here. Puppet Shark, you proud of them? What do you think, Puppet Shark? You proud? Puppet Shark's proud. Trevor's doing well right there. I am so tired. Oh, I gotta sleep. I'm gonna sleep all weekend. Just all weekend. I'm gonna wake up and you say, "How was your weekend, Brian?" I say, "I slept." Well, I think that's got it. Hey, Brian, when are you done with this? I need some help. I'm trouble access to the Shiny Widgets Gallery. It says it cannot be found. Caleb, can you hop on? Are you on Discord, Caleb? I'm gonna start setting up class here in a second. When we starting class, we figured out Hall of Fame. Oh, nice job. Trevor's in the Hall of Fame. Check your points. Oh, I clicked it and then I didn't click it. Aw, Zaid. Thank you. Zaid, we're throwing out some 50 points for Zaid and the positivity right there. I appreciate that. You know, we're here to have fun. We're here to relax. Swing by anytime. Ask those questions. We'll crack jokes. We'll have some fun. And we'll get some work done. We'll have jokes. We'll crack jokes, have some fun, and get some work done. That's what we do here on Stat Tool 1. I'm going to go play with my guitars. Here with all my guitars. With that, everybody, we will be back. I'm going to see Caleb. Are you on Discord? That's the easiest way for me to hop on and take a look at what's going on. Let's say goodbye. Oh, my green screen. What are you doing, green screen? Not that I'm on a green screen. No green screen. I will see everybody later. Bye for now, everyone. Bye.